In this video, I want to consider a type of measures of central tendency called the arithmetic mean. The arithmetic mean is denoted with X bar. Another word for it is average. It is the ratio of the summation of all the observations or items or values to the number of observations or items or values. For example, if we have numbers x1, x2, x3 and so on to xn, it doesn't matter how many. For us to calculate it, we have that it is given that x bar mean or average is summation of the individual items or observations starting from 1 to how many they are, n over n. So we're going to consider how to calculate or compute the mean for ungrouped data and also grouped data. So let's first of all see for ungrouped data. This question says the individual ages in years of 10 students in a presentation class are given as 19, 22, 21, 23, 18, 20, 26, 27, 25 and 29. Compute the mean age of these students. Now we are already told that there are 10 students. It means these values will be 10 in number: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So for us to compute the mean, it will be summation of the individual values, and individual started from 1 and they are 10 in number over n. So what we're going, this will be 19 plus 22 plus 21 plus 23 plus 18 plus 20 plus 26 plus 27 plus 25 plus 29 over 10. And when we add the above, we're going to get about 230 over 10, so which will give us 23. So the mean age is 23 years. When it is in terms of frequency, which means some of the observations or items occurs more than once, the mean or average will be given by summation of fi xi, individual starting from 1 to n, over summation of f, individual starting from 1 to n. This is the total frequency. So let's see an example. Remember, you can easily write this formula to be summation fx over summation f, but this is this very good way to represent it in statistics. This is the statistics language. This is just the ordinary language. This example says, given the frequency distribution of the scores of the students in a 10-point class test below, obtain the average score of the students in the test. Remember, average is another word for mean. So for us to do that, we need to first of all do this table to make it easier for us. That is, we create serial number, then we create score, and then number of students is the same thing as the frequency f. So we have the serial number, we have the score, we have the number of students, which is the frequency. So the next thing we now need to do is to create the next table, which is f and x. So this times this is 0, 2 times 1 is 2, 2 times 5 is 10, 3 times 6 is 18. Remember, in the course of this, mutilation is not allowed. What I mean by mutilation is if you write 3 and you are correcting it to, let's say, 4, and you're doing so, this is not your table. We need to be very neat. So 4 times 4 is 16, and 5 times 9 is 45, and 6 times 9 is 54, and 7 times 5 is 35, 8 times 3 is 24, 9 times 4 is 36, and 10 times 1 is 10. So the next thing is, because our formula mean is given as summation f x individual starting from 1 to 11. You see the serial number, they are total 11, so to 11 over summation of f, which is, it starts from 1 to 11. So it means we need to add up this, we need to add up f, this. So if we add up the whole of f, we're going to get 50. If we add up the whole of this, we're going to get 250. So this becomes 250 over 50, which gives us 5. Another example here, this type is what we call grouped data, because you can see instead of having only singular values, we have them grouped. So what it means is that for this score, those that scored 0 to 4 marks are 3. Those that scored 5 to 9 are 6, and so on. So it doesn't really show us exactly how many people that scored 1 or 0 or 2 or 3 or 4. We're just told that those that scored from 0 to 4, that they are 3. We're not told exactly how many people that scored 5 or 6 or 7 or 8 or 9. We're told that those that scored from 5 to 9, that they are 6 people in number, and so forth. So because of that, we don't really have our x value, because our mean is given as summation f of x, f and x over summation f. So f starting individual values starting from 1 to 1, 2, 3, 4, 5, 6 to 6, starting from 1 to 6. So for us to get our x, what we need to first of all do is we have what we called midpoint, which will now be our x. The midpoint means add these two together, divide by 2, which is their average. So 0 plus 4 is 4, divided by 2 is 2. The shortcut for this is, for example, when you have large values, instead of using a calculator and be wasting time, you check the class intervals. If you see the class intervals, they are 5, 5, 5, 0, 5, 5, 5, 5. If you also check here, 5, 5, 5, 5. So what you need to do is, for example, 5 plus 9 is 14. 14 divided by 2 is 7. So you can see their gap is also 5. So the class interval is 5. All I need to do, instead of saying 10 plus 14, 24, divided by 2, 12. All I need to do is 7 plus 5 is 12. 12 plus 5 is 17. And 17 plus 5 is 22. 22 plus 5 is 27. So if I still do this plus this divided by 2, I'll get this. This plus this divided by 2, I'll get this. This plus this divided by 2, I'll get this. So this is the short form, the shortcut of it, adding the number that is the class interval. Okay, having gotten our x, we can now have our fx, which is this times this gives us 6. This times this gives us 42. This times this gives us 96. Yeah. This times this gives us 153. This times this gives us 110. This times this gives us 54. So, sorry for writing the formula here. We're supposed to write the addition, the summation under here. So let me just shift here. The addition, if we add all of them, we're going to get 461. Sorry, one hand is holding the camera, one hand is writing. So 461. So we need to add f. So if we add f, we'll get 33. So this, let me just finish it up here. So this formula now becomes 461 over 33, which becomes approximately 13.97 to 2 decimal places. You can leave it in 4 decimal places as well.